Welcome to section 3.4, where we're going to talk about the chain rule. Before doing the chain rule, I'm going to do an example without it, like if it was 7x plus 5 and the whole thing is squared. Then take the derivative of that. Well, without the chain rule, what we would need to do is go ahead and multiply this out, combine like terms, etc. So I'll do that. The algebra would look like square the first term, that's going to be 49x squared. Multiply these two, that's going to be 35x. Double the result, that's 70x. And finally, square the last term, that's a 25. Okay, now take the derivative term by term. So the derivative will be, let's see, 2 times 49, that's 98. So 98x. The derivative right here is going to be just 70. And the derivative of 25 is 0. Now I noticed that these numbers are even, so I could actually factor out a 2. This would leave 49x plus 35. Oh, wait a second. I could factor out a 7 from this and a 7 from this. So if I factor out a 7, that's going to be 7x. And if I factor out a 7, that's 5. And now the 7 that I factored out, I'm going to put it right here. Now, take a look at the original problem and the final answer that I got. So with this one, instead of doing all of this algebra, what we could do is do the power rule. Have the 2 go down in front and multiply. That's that one. Subtract 1 from the exponent, so it's just going to leave 7x plus 5. And then, what is this extra 7? Well, this extra 7 comes from the derivative of what's inside the parentheses. So basically, when you have one function that gets substituted into another function, then you need to take the derivative, but you only do one at a time. So for the squared function, the derivative would be 2 times whatever the parentheses are. And then after that, you would multiply by the derivative of the inside. That would be 7. So that is what's known as the chain rule. So the chain rule basically goes like this. If you're taking the derivative of a function and that one has another function substituted into it, so this would be the square function and this g would be the 7x plus 5, the one that's inside of the parentheses. So you take the derivative of the outside function first and you leave the inside alone. And then you take the derivative of the inside. So for example number 2, let's not do it the long way, let's do it using the chain rule. So how about if it was, the function is going to be sine is raised to the 5th power. So the sine x is the inside function, the raise it to the 5th power, that's the outside one. So that's where you start. So start by doing the power rule, the 5, you bring it in front and multiply, and then subtract 1. So it's going to be 5, and then sine of x is raised to the 4th. And then for this function that was on the inside, you then take the derivative of sine, which is cosine. And then example number 2 is finished. Then on to example number 3. So how about if the function's y equals the square root of x squared plus 9? So previously we've done the derivative of the square root. And as I mentioned previously, it's best if you just remember the derivative of the square root function is 1 over 2 times that square root function. So this shortcut can save you a lot of time. Otherwise, you'd have to write it to the 1/2 power, then do the power rule, and you're going to get a negative exponent, and then get rid of the negative exponent. But this right here will save us some time. So, because it's the square root function, it's going to be, the derivative is going to be 1 over 2 times that square root function. And then for the chain rule. So sometimes I just abbreviate it as CR, or chain rule. Now take the derivative of the inside. So the derivative of the inside would be 2x plus 0. So that's just going to be 2x, and multiply with the 2x. And then this one could be simplified a little bit because that 2 on top and that 2 on bottom, they can cancel. So it's just going to leave a single x on top, and then the square root of x squared plus 9 is on the bottom. How about example number 4? How about y is equal to secant of e to the 5x? Now the reason that it's called the chain rule is because chains have links, and those links can go on and on and on. With this one, there was only 2 links in the chain. There was the square root function, so that was the first link right here. And then the derivative of the inside, that was the second link. So that would be like this. It was a chain rule, but a very short chain. This one is going to have 3 links because this one has 3 functions. The outside function is secant. Substituted into that was the e function, and then substituted into the e function was the 5x. So we'll need to do 3 derivatives. First of all, the derivative of secant. Well, the derivative of secant is secant times tangent. And don't just automatically think it's secant x, tangent x. The derivative of secant is secant times tangent, but this e function needs to stay the same. Because as I mentioned before, you can only do 1 derivative at a time. So I've only taken the derivative of this secant. Then do the chain rule. And the derivative of the e function is itself. Then do the last link in the chain, or one more chain rule, and take the derivative of the 5x, and that is a 5. And in here, nothing can be combined or simplified, so number 4 is actually done. For example, number 5, how about if the function is 1 over x, let's go with x cubed minus x. So with this one, you could actually use the quotient rule because this is a quotient, but you could also rewrite this as x cubed minus x is raised to a negative 1. And then we could take the derivative by using a combination of the power rule and the chain rule. First of all, using the power rule, this negative 1, you would need to bring it in front and multiply, and then subtract 1 from the exponent. So that's going to be negative 1 times the parentheses x cubed minus x is now to the negative 2. And now do the chain rule. So inside the parentheses, you take the derivative of this. That would be 3x squared minus 1. And then the only thing with this is don't leave any negative exponents. So this is going to have to be moved to the denominator. So the derivative final answer will be there's negative and there's 3x squared minus 1 in the numerator. And there's x cubed minus x to a 2 in the denominator. So the chain rule is extremely important. We use it over and over and over again. And even in the next section with implicit differentiation, it's basically the chain rule, as long as you understand the chain rule very well. So for example number 6, let's try something a little more challenging. How about g of x is equal to a 1 plus x squared over 7x, and then that's to the 4th power. So we start on the outside. Take the 4, bring it down in front, and multiply. Leave what's in the parentheses alone for right now, just copy it down. Subtract 1 from the exponent, and there's the very first part. And then take the derivative of the inside. So for this function, sometimes I feel like spelling out the whole thing. So now do the chain rule. Take the derivative of the inside. Well, for that, we need to use the quotient rule. Part of the quotient rule says that the bottom needs to be squared. The other part of the quotient rule says start on the top and take the derivative. So that's going to be a 2x. And then that gets multiplied with the denominator minus, leave the 1 plus x squared alone, and then take the derivative of the 7x, so that's just a 7. And I just barely have enough space to fit it in there. All right, now we need to simplify, especially this part right here. So this part, you could leave it 4 and 1 plus x squared over 7x is cubed. That part can stay there. And then this, when you multiply those, it's going to be 14x squared. And then when you have this minus and you distribute the 7, that's going to be minus 7x squared. So 14x squared minus 7x squared is going to be 7x squared. And then when you distribute, this will be a negative 1 and then times the 7, so that's negative 7. On the bottom, oops, it's 49x squared. And then this actually could be simplified a little bit more. So in here, this has a 7, this has a 7, so you could factor out a 7, and then that 7 will divide into 49. So factor out the 7, that means that it's going to leave x squared minus 1. And then the 7 that you factor out, have it divide into this and leave 7x squared. And there we go, Bob's your uncle. Then for the last example, I'm going to do 2 that look very similar. So for example number 7, y is equal to this. And then compare that with y is equal to so what's the difference? Yes, you're right. This one has an extra x. So what this means is you have a product of the sine x function and this tangent function. So this one, we're going to start by doing the product rule. Because the x is missing here, that means it's saying sine, and then all of this was substituted into the sine function. So that means this one is not the product rule, this one is the chain rule. So for the one on the left, the derivative of sine is cosine. And because you can only take one derivative at a time, you have to leave this exactly as it is. So it's going to be cosine of tangent of e to the x squared. And then take the derivative of tangent. The derivative of tangent is secant squared. And then leave the e function alone. Now take the derivative of the e function, which is the e function. And finally, take the derivative of x squared, which is 2x. That one is finished. There's nothing we can simplify or combine, so that one's done. Then for the one on the right. So for this, we need to do the product rule. The derivative of sine is cosine of x, and then leave the tangent function alone. And because they're multiplied, I don't really need to put parentheses around it. These parentheses right here were just extra. So that's half of the product rule. The other half goes plus, this time leave sine alone, and now take the derivative of tangent, and that is secant squared. And then take the derivative of the e function, which is the e function. And then take the derivative of x squared, which is 2x. And so you'll see that these two answers are quite different. Whether it has an x there or not, it definitely makes a difference. All right, I'll see you soon.